My chemistry faithful, check it. Going to make a quick video on the prep for acids and bases. I just opened up my reference table to page 6. No, you cannot see it. You can only see the screen. I will spare you from staring at me. Which of these compounds are classified as acids? All right, well, I'm going to go through and just start checking what's going on here. I see I see HCl is on my acids list. I see HNO3 is on my acids list. I see H2CO3 is on my acids list. H2SO4 is on my acids list. Okay, good. I don't see NaOH. Oh, wait, I see it. It's on my base list. So this is not an acid. Okay, so bye-bye. A is obviously not the right answer. NaCl is sodium chloride, which is a salt. A salt is neither an acid or a base. NH3, I find NH3 on my base list, so that's a base, not an acid. I don't see HBr on the list for acids and bases. So we first question found an acid that is not on our common acids list. But you should be confident it's an acid because it starts with the H. So whenever I start with an H like that, I'm going to be an acid. And these things don't know want to delete, so we'll go like that. Okay, moving on. According to one acid-base theory, doesn't tell you which one. A base is what? It's either an acceptor or a donor. Well, I know what H plus donor is definition of acid. Na plus acceptor or donor is all fodder, if you will. That's a distractor. We don't worry about Na plus in acids or bases. We changed the definition of a base to be an H plus acceptor in the Bronsted-Lowry theory of acids and bases. So that would be correct. That's the one that matches. A substance that dissolves in water and produces hydronium ions. Hydronium ions, H3O plus. And we talked in the notes a lot about how that equals H plus. So if I'm going to make H pluses in solution, I am an acid. Good. When dissolved in water, Arrhenius base yields. Well, I need OH minus. And if I can't remember what OH minus is, by the way, I'm going to flip back to table E, and there is OH minus. It's called hydroxide. So we have the name for HE on table E. I'm sorry, of OH minus on table E. All right, according to one acid-base theory, an acid is, well, it can't be an acceptor. An H plus acceptor. We just learned that is the definition for a base. We don't talk about acids or bases in terms of being an OH acceptor or donor, even though that is a better distractor than Na plus. So B is an H plus donor. Acids donate H plus or create H plus in solution. Potassium hydroxide is a base because it contains OH minus ions. This one's pretty straightforward. We're pretty good right now with acids are H plus and bases are OH minuses. All of these are things are other distractors. That's a major distractor. That's a major distractor. This H plus is an acid, so that doesn't fit our problem. Moving right along to try and keep this moving. A base reacts with an acid to produce water and salt every time. This is that generic equation that we have. Ammonia, water, and methane. All distractors. Given the equation, HCl with water makes aqueous with Cl. Well, this is going to be H3O plus or H plus. Just to balance the equations, it's going to be H3O plus. I'm going to lose the H off of this, add it to this, and make it H3O, which is called the hydronium ion. Hydronium and hydroxide are close, so you got to be able to differentiate between those two words. Which solution reacts with LiOH to produce a salt and water? Oh, well, isn't it an acid plus a base makes salt and water? So an LiOH is a base, so I need the acid. In other words, which one of these are acids? This is right on my acids list, table K, page 6. H2SO4 is sulfuric acid. Which balance equation represents a neutralization reaction? This is the neutralization reaction right here. Acid plus base produces salt and water. Oh, look, here's an acid, here's a base, here's salt, here's a water. Whoa, it's the first one. Isn't that cool? BaCl2 is not an acid, that's a salt. KClO3 is a salt. Mg is a metal, single replacement, not a double replacement. So we know it's a double replacement reaction too. 11. When the pH of an aqueous solution is changed from 1 to 2, it's a 10 times change for every 1 pH. So now it's going from 1 to 2. It's actually decreasing, though, because I'm becoming more basic or less acidic. I got to remember that number's got to get smaller for the H plus concentration to increase. It's kind of backwards in that regard. A solution with a pH of 11 is first tested with phenolphthalein and then with litmus. What color did each indicator turn? Okay, so now I need to use table M on page 6. pH of 11, phenolphthalein. Phenolphthalein, 11 is to the right of 9, so it's going to be pink. So I can get rid of phenolphthalein is colorless, phenolphthalein is colorless. I see phenolphthalein is pink and pink. I need that. And then litmus. Litmus, 11 is to the right of 8.3, so it's going to be blue, according to the reference table. And I didn't cut and paste that reference table to bring it out to show you, but I'm just reading it, and I'm guessing you can read along with me. All right, moving right on. Right along. On to 13, we got to get through 20 of these things. An acidic solution could have a pH of, well, I know 7 is neutral, Bob, and I know above 7 is base, so the 10 and 14 are all bases. That means 3 is a potential pH of an acid. The most basic solution, so the farthest towards 14, or the highest number. There you go. This is going to be, I think, a backwards question. Which change of pH represents a 100-fold increase? Well, 100 times is 10 squared, which means my pH changes twice. So my pH changes once in this, it changes once in this, so we're good there. I know it's either B or D. And then an increase in concentration means I'm becoming more acidic, which means I'm going from 3 to 1. There you go. Change pH 2 times, and it's got to get smaller to make it more acidic. That's how that works out. All right, 25 milliliter sample is neutralized by 32.1 milliliters of this. This is MAVA equals MBVB, your titration equation. And then we just got to plug this stuff in and do some calculating. So 25 milliliter sample of acid. That's 25. Don't know the molarity of the acid, so that's X. Molarity of the base, 0.15 times 32.1. Okay, so I'm going to reduce that first. I'm going to, in the calculator, type in 32.1 times 0.5, which is basically half of that. That is 16.05. 25x. In order to get x by itself, divide by 25. When I do to one side, I have to do to the other. So I got 16.05 divided by 25. That's going to equal 0.642 in my calculator. I don't see it. What did I do wrong? Trying to figure out what's wrong here. 32.1 mole, 32, yeah. Okay, let's try it one more time. 0.15 times 32.1. Oh, there we go. I made a mistake. This is 4.815. So I made a quick error, but notice when I made an error and the answer I wanted was not there, now when I divide 4.815 by 25, I get 0.1926. So I made a calculator error, 0.193. Bam, answer. Got lucky there because the answer that my calculator gave me that was wrong was not an answer for me to choose. That's when you're in a lot of troubles when you make a calculator error and the answer is actually there for you to pick. You're probably going to pick it. I probably would too. All right, this is another MAVA question, except for this time I'm given the molarity of the acid. So it's 0.5 times X is 100 milliliters times 0.1. So real quick, I'm gonna do 100 times 0.1 in my calculator. I get 10. And then 0.5 x equals 10. Divided by 0.5, 10 divided by a half should be 20. 20 milliliters. Got it. B. Which indicator is yellow in a solution of 9.8? 9.8 is a base. So who's on the right-hand side? It says yellow. Look at that, methyl orange right off the top. Methyl orange's range ends at 4.4, so 9.8 is definitely above that. 2 more problems and we are done with this video. Let's get through it. When a pH of a solution is changed from 4 to 3, it's a 10 times change. And from 4 to 3 makes it increase my concentration. So I'm going to increase by a factor of 10. Perfect. That's B. Which solution has a pH greater than 7? In other words, which one is a base? Sugar is not a base. NaCl is a salt. KCl is a salt. None of them are even acids. Look at that. I got one base because that's got a pH greater than 7 by definition. And with that, you are now through your acids and bases prep.